Hello. Today I am going to show us a circuit that can be used to auto-control an AC standing fan. So, here is the circuit. It makes use of a temperature sensor. The circuit is an automatic circuit. The temperature sensor can be any type of temperature sensor. Here I made use of LM35. You can make use of any of the temperature sensors. So, the circuit is made up of a power source. Here is the power source, which converts an AC power source to DC power with multiple outputs, 1, 2, 3, and the physical design can even have more than that. So, we also have the Arduino Uno microcontroller that controls the entire circuit. This is the LCD display screen where the temperature of the room is being displayed. We have 3 5-volt relays, which represents each one of the mechanical switches of the standing fan. These are the indicators, indicating the speed level of the fan. So, this is a DC motor, of which we know that a DC motor cannot be run under or with AC power. It is just here to show us the simulating demonstration. This switch here is just to describe the physical mechanism of the standing fan mechanical switch. So, this switch here is just like a representation of the switch here. That is this configuration we are seeing here. So, we know that the coil of an AC standing fan has 4 wires which are in color codes. It can be red, blue, white and black, or red, blue, green and black. It majorly comes in red, blue, white and black. But in this design, I represented the white colored wire with green wire. So, we also know that it is majorly only 2 wires that supply power to the AC standing fan. We have the red or hot or life wire, usually in brown or dark red, the neutral wire, either in black or blue or dark blue color, and the earth wire in yellow stripe for those fans that have 3-pin plug. These wires supply power to the fan, and the physical mechanical switches of the standing fan seems like this for some style of fan. These are this is the red button, blue button, green button, and the black button. They represents the speed levels of the fan. As we can see the description, coil speed wires. This red wire signifies the highest speed of the fan, followed by this blue, followed by this green. Here is where you can turn off any of these switch buttons. So, it is the hot wire that is being regulated here. So, how it works is that this hot wire can either connect to this, or connect to this, or connect to this at a time. It cannot connect to all of them at the same time. It will just connect to one at a time, just as you can see in this place. So, this thing can just either connect to this, or connect to this, or connect to this. Just as we can see, that's how it is in the mechanism of this. So, the neutral wire that came from the power source is connected directly, leading to the black wire of the coil. So, it is just run straight to the coil and connect to the black or neutral wire of the coil. Then the hot wire is what is being regulated, as you can see here. This is our power source. This is the hot wire. I represented this terminal to be the hot and this terminal to be the neutral. So, if we come down to this place, just like what I said, the relays are used to represent mechanical switch of the fan. So, the mechanism circuit is an automatic switch. So, this is the hot wire which is being regulated here. It can either connect to this relay or connect to this relay. Depending when any of the relays is being energized, it will connect that one. So, and any relay being energized depends on the programming. This microcontroller is what controls it according to the input coming from the temperature sensor. So, here in this place, I just used this DC motor here to show us the connection. I told us that I'm just using this motor here to show the working of this circuit once any of the relays is being energized. If I just rotate this and connect it to either green, blue, or red, the fan will be rotating, and if I connect it back here, it will stop. So I'm going to show us the demonstration, but I will have to go to the codes to look at the codes. Here are the written code for the fan. So, you just define your library and then you define pins, include your libraries, define the pins. I believe you can see the codes. I will just go through it so that you can be able to see it and be able to replicate it and do your own. I'm just trying to show us everything here before I go into the brief description of the codes. There are so many algorithms written here, different in so many conditions. Let me just start from this place under the loop. Inside the loop, we have this condition written here. It says white value is greater or equal to voltage. The blue value is greater, and the blue value is greater or equal to voltage, or the red value is greater or equal to voltage, and the temperature value less or equal to 28.99. That all of the relays should be turned off and all indicators also should be turned off. That's how this one works. There are different conditions here. This one here, it also shows that all relays should be off. This will make the fan to stop or be automatically off. Here it will display that fan is at level 1. Here it will display that fan is at level 2, and so on. That's how the codes were written. That's how they were written. So, we go back to this place to show us the demonstration. So, let's run the simulation. As we can see, the temperature value is 29.33 degrees centigrade. So, this indication here is showing that the green relay is being turned on. So, as you can see, the green relay is connected. So, if I connect this wiper now to G label, this fan will be rotating as you see. This is showing that power is supplied to the fan. If I increase, let me increase the temperature of the room. So, the blue relay now is connected, and the green relay is automatically disconnected as we can see. So, the blue indicator is on as we can see. At what temperature? Let's see the temperature level. At 31.28 degrees Celsius. So, if I connect this wiper to be label terminal, the fan will be rotating. If I also increase the temperature level to rise, it enters into that of the red relay as we can see. As we can see, the red relay is energized while the blue relay is de-energized. If we go back to this place and rotate the wiper to connect to their label terminal, the fan is rotating. And at what temperature level? 33.24 degrees Celsius. So this is just the demonstration. I've told us that in physical design, this manual switch cannot not be there again. It will just be connected directly to the fan coil. Once any of these relays is being energized, the fan will automatically turn on. So that's the mechanism. You can use this circuit now too. That's if you just open your standing fan and bring out these wires and connect them to this circuit, your fan will be automatically controlled. There's no need for you again to go and be pressing the buttons. Once the temperature according to the programming codes reaches to the limit or set threshold, the fan will be automatically rotating. So, that's the demonstration. Thanks for watching. Do well to subscribe to my channel for more updates.